This is an audiovisual presentation on financial arithmetic. Let's begin by looking at what we call amortization. Amortization is the paying off a loan plus interest by making a series of regular equal payments. Now let's look at this illustration. Assuming you want to buy this car and you have gone to your bank to borrow $10,000, in which you are supposed to do equal monthly payment for 4 years. So at the end of the 4 years, your bank expects you to pay the principal together with the interest charged based on the equal monthly payment for 4 years. Now let's look at the transaction. Let's consider these two views. Number one, the banker's view. Now with the banker's view, the banker expects the customer to pay the money together with the interest on monthly basis for 4 years with the interest compounding. Now at the end of the 4 years, the banker expects the customer to pay the money borrowed together with the interest based on the equal monthly payment for 4 years. Now the amount of money the customer is going to pay at the end of the 4 years can be calculated using the formula A equals P into bracket 1 plus R over M exponent N, where A is the amount, the total amount the customer is going to pay at the end of the 4 years. P is the principal, that's the amount the customer borrowed from the bank. 1 is a constant, R is the interest rate, and M is the number of months in a year. And N is the total period of payments. The total period of payments. The total period of payments. That's the number, the total number of months. Now let's consider the customer's view. Now the customer can also decide that instead of paying the bank on equal monthly basis, he can also create a sinking fund in which he can pay his equal monthly payments in the fund, that at the end of the 4 years, he takes every money in the sinking fund and goes to the bank to pay. That is the customer's point of view. Now, at the end of the 4 years, the customer now takes all the money in the sinking fund and goes to the bank to pay. That is the customer's view. If you want to calculate the amount that will be in the sinking fund at the end of the 4 years before the customer takes to the bank, we use the formula A equals R times 1 plus R over M exponent N minus 1, all divided by R over M. So this formula will help you to know the amount that will be in the sinking fund at the end of the 4 years before the customer goes to take and go to the bank to pay. Now these are the two views. Now, how do we calculate the monthly payments? Take note that with the banker's point of view, the formula to use in calculating the amount that the customer will pay the bank at the end of the 4 years is equal to, the formula is A equals P into bracket 1 plus R over M exponent N. And this is the customer's view, that when you create the sinking fund and do the equal monthly payment into the sinking fund and takes the money at the end of the 4 years and goes to the bank to pay. If you want to find the amount that will be in the sinking fund at the end of the 4 years before he takes to the bank to pay, we use the formula A equals R times 1 plus R over M exponent N minus 1 divided by R over M. Take note that at the end of the day, the amount from this formula is the same as the amount you are going to get using the second formula. That is the amount from the banker's view at the end of the 4 years, and the amount from the customer's view at the end of the 4 years is the same. That means that we can equate the two equations. We can equate the two formulas. Now equating the two, we have P into bracket 1 plus R over M exponent N is equal to r times 1 plus r over m exponent n minus 1 divided by r over m. Now, the monthly payment is equal to r. The monthly payment is equal to r. So we can make r the subject. And when we make r the subject, the r is the monthly payment you are supposed to do, either to the bank or into the sinking fund. Now let's proceed. Example: assume that you have taken out an amortized loan for $10,000 to buy a new car. The yearly interest rate is 18%, and you have agreed to pay off the loan in 4 years. What is your monthly payment? I go over the question again. Assume that you have taken out an amortized loan for $10,000 to buy a new car. The yearly interest rate is 18%, and you have agreed to pay off the loan in 4 years. What is your monthly payment? Now, solution. The principal, that's the amount you borrowed from the bank, is $10,000. N is the total number of months. Because we have 12 months in a year, and the period of payment is 4 years. If you want the total number of months, is 12 times 4, and that is 48. R over M. R is the interest rate, that is 18%. And M is the number of months in a year. So 18% is 18 divided by 100, and that is 0.18 divided by 12. Now, when we divide 0.18 by 12, the result is 0.015. Now, we said that if you want to find the monthly payment, we equate the two amount formulas. So P into bracket 1 plus R over M exponent N is equal to R times 1 plus R over M exponent N minus 1 divided by R over M. That is the formula we have. So P is the principal, that is $10,000. R over M, after calculation, we had 0.015. And N equals 12 months times 4. That gives us 48. So by substitution, wherever we see P, we substitute it by 10,000. We have 1 plus R over M give us 0.015. So we do that substitution. N give us 48. So we also do the substitution here. We are done with the left hand side. So this is equal to R. We have 1 plus R over M is also 0.015. So we have plus 0.015 exponent N. And N is equal to 48. So we have exponent 48 minus 1 divided by R over M, that is 0.015. When we divided R by M, we have 0.015. Now let's proceed. So we have 10,000 times 1 plus 0.015 exponent 48 is equal to R times 1 plus 0.015 exponent 48 minus 1 divided by 0.015. Now, when we simplify the left, that is when we add 1 to 0.015 and we raise it to the exponent 48, whatever we are getting, if we multiply the answer by 10,000, we are supposed to get 20434.78289. That's on the left hand side, and this is equal to R times now 1 plus 0.015 raised to the power 48 minus 1 divided by 0.015 is equal to 69.56521929. Now take note that we are solving for R, where R is the monthly payment. So we divide the right hand side by 69.56521929, and we also divide the left hand side by the same 69.56521929. Now in doing that, on the right hand side we are left with R, and on the left hand side we have 20434.78289 divided by 69.56521929. So when we do this division, we have $293.75. And this is equal to R. So R equals $293.75. And this is the monthly payment. This is the monthly payment that the borrower must pay either to the bank monthly for 4 years or to pay into the sinking fund, and at the end of the 4 years he takes the money from the sinking fund and go to the bank to pay. Take note, the monthly payment is $293.75. Now let's look at what we call amortization schedule. A list showing payment by payment, how much is going to principal and interest, is called an amortization schedule. Now let's look at this example so you understand what we are talking about. Assuming you need a loan of $5,000, your banker loans you the amount at a 12% annual interest rate, which you agree to pay back in 3 equal monthly installments of $1,007.12. I go over the question again. Assuming you need a loan of $5,000, your banker loans you the money at 12% annual interest rate, which you agree to pay back in 3 equal monthly installments of $1,007.12. Construct an amortization schedule for this loan. Now let's look at the solution. The end of the first month. Take note that the interest rate per year is 12, but the borrower has decided to pay the loan together with the interest within 3 months equal installments, within 3 months. So the end of the first month, take note that the amount borrowed from the bank is $5,000. So the monthly interest rate will be 1%. Why is it 1%? Because the yearly interest rate was 12. And because we have 12 months in a year, when we divide 12 by 12, we have 1% to be the interest rate per month. So monthly interest rate is equal to 1%. Now the simple interest will be equal to P times R times T divided by 100, where P is the principal, R is the rate, T is the time, and 100 is the constant. So simple interest is equal to 5,000 times 1 times 1 divided by 100. This is equal to $50. So the simple interest, the monthly simple interest will be $50. Take note that your payment is $1,007.12, and therefore the $50 you have calculated pays the interest, and the rest, that is $1,007.12 minus the $50, which is equal to $1,650.12, is applied to the principal. So take note, the monthly installment, the monthly payment is $1,007.12, but when we calculated the interest on the principal, the simple interest, we have $50. That means that the $50 pays the interest, and the rest, how do we find the rest? We subtract the $50 simple interest from the monthly payment, that is $1,007.12, and the result is $1,650.12. This is applied to the principal. So for the second month, it means we are now borrowing the 5,000 minus 1,650.12, that is 1650.12. When you subtract 1,650.12 from $5,000, we are left with 3,349.88 at 1% monthly interest. So this will now be our current principal. This will now be our current principal, because the first payment, that's the 1,007.12 that we paid, has paid part of the principal and part of the interest. So the new principal will now be 3,349.88 at 1% monthly interest. Now let's proceed. The simple interest, because we now have a new principal, our simple interest, which is equal to PRT over 100, will now be the principal, that is 3,349.88 times 1, that is the interest rate for the second month, times 1, that is 1 month, divided by 100, and this is equal to $33.50. So the $33.50 pays the interest. The $33.50 pays the interest, and the rest, how do you find the rest? You have to subtract the $33.50 we have gotten from the monthly payment of $1,700.12. And so when we do that, we have $1,666.62. $1,666.62. So for the third month, it means we are now borrowing 3,000, that's the previous principal, 3,349.88 minus $1,666.62, and the result is $1,683.26 at 1% monthly interest. At 1% monthly interest. So this is now our current principal. This is now our current principal. This is now our current principal. So we also calculate the 1% monthly interest. So the simple interest, which is equal to PRT divided by 100, will be equal to the principal, that is 1,683.26, times 1, that is the interest rate per the month, times the time, that is 1 month, divided by 100, and the result is 16.83. That's the simple interest on the principal, 1,683.26. So the interest is $16.83. Also, the $16.83 we have calculated pays the interest, and the rest, how do you find the rest? Take note that during the third month, we are doing our last payment of 1,007.12. So we still subtract the interest we have calculated based on the current principal. We subtract it from 1,007.12, and the result is 1,683.29. 1,683.29. 1,683.29. Now let's proceed. Assuming that for the fourth month you were to make a payment. Take note, there is no fourth month, but for you to understand, I want to show you something here. Now, for the fourth month, you are now borrowing 1,683.26 minus 1,683.29. That's the previous, the just calculated amount left. And this is equal to minus $0.03. That means that by the time you do the third monthly payment, you have overpaid, and the bank will now be owing you by $0.03. It means that you don't even pay for the fourth month. So it is 3 months equal payments. I brought this to show you that for the fourth month, if you try to pay, it means you are even paying more than you are supposed to pay. Because if you look at the difference, we have minus 0.03. That means that when we do the third monthly payment, you have even overpaid the money you are supposed to pay. Now let's continue. So the amortization schedule, we have the payment number, we have the amount of payments, we have the interest payments, we have the applied to principal, we have the balance. Now we have 3 months, so month 1, the second month, the third month. The amount of payment was equal. That is 1,007.12 for the first month, 1,007.12 for the second month, and 1,007.12 for the third month. Now let's consider the first month. For the first month, the amount of payment was 1,007.12. And take note that when we calculated the interest, don't forget that this is the amount that we took from the bank. This is the amount that we took from the bank. That's the principal. And this is the amount of payment, the monthly payment. When we calculated the interest, the monthly interest on the 5,000, don't forget that we had $50. And so we subtracted the $50 from the monthly payment, and that gave us $1,650.12. Now, if you want the new principal, we subtract the $1,650.12 from the $5,000, and that gives us $3,349.88. And this becomes our new principal, because when we do the first monthly payment, we have paid part of the principal and we have also paid part of the interest. So the new principal will now be $3,349.88. Now, during the second month, we also paid $1,700.12. When we calculated the monthly interest on the new principal, that is $3,349.88, we had 33.50. And so we subtracted the 33.50 from the second month payment. That gave us 1,666.62. So if you want the new principal, we subtracted 1,666.62 from 3,349.88, and the results give us 1,683.26. So it means that this is the new principal. This is the new principal, because by the time you do the second month payment, you have paid the greater part of the principal and also the greater part of the interest. So this is now our new principal. Now, during the third month, we also paid $1,007.12. So when you calculate the monthly interest on $1,683.26, we are 16.83. Then we subtract the 16.83 from the third monthly payment, and that gives us $1,683.29. $1,683.29. So if you want to know the current principal to move forward, we subtract 1,683.29 from 1,683.26, and the subtraction gives us minus 0.03. And this minus means that by the time you do the third month payment, you have even overpaid the loan together with the interest by 0.03. This is what we call the amortization schedule. This is what we call the amortization schedule. Now, let's proceed. We have annuity. An annuity is a series of payments made at fixed intervals of time. An annuity is a series of payments made at fixed intervals of time. Examples of annuities are regular deposit to a savings account, monthly insurance payments, and pension payments. The most common payment intervals are yearly, that is once a year, semi-annually, twice a year, quarterly, 4 times a year, and monthly, that's once a month. Now let's look at the ordinary annuity. S subscript n is equal to R times 1 plus I exponent n minus 1 divided by I. Sn is the sum of series of regular payments. R is the amount saved, and N is the total period of payment. N is the total period of payment. Now let's look at how to calculate this annuity. Let's look at how to calculate this annuity. Example: Alan decides to set aside $50 at the end of each month for his child's college education. Alan decides to set aside $50 at the end of each month for his child's college education. If the child were to be born today, how much will be available for her college education when she turns 19 years old? If the child were to be born today, how much will be available for her college education when she turns 19 years old? Assume an interest rate of 5% compounded monthly. Now let's look at how best we can solve this problem. First, we assign all the terms. R is the amount saved, the amount that you are saving. So R equals $50. I is the interest rate divided by the number of months in a year, that is 12. So I equals 5% over 12, and 5% is 5 over 100. So divide by 12. Now 5 over 100 is 0.05. So 0.05 divided by 12 is equal to 0.004166. Now N is the total number of months. So it's 19 years times 12 months. And this is equal to 228 months. So by substitution, we have Sn equals 50 into bracket 1 plus I exponent n minus 1 divided by I. Now let's proceed. By substitution, we have S subscript n, that is the sum, is equal to 50 into bracket 1 plus 0.004166 exponent 228 minus 1 divided by 0.004166. Now Sn is equal to 50 into bracket 1.004166 exponent 228 minus 1 divided by 0.004166, and Sn is equal to $18,965.68. So this is going to be the amount accumulated when the child turns 19 years old. This is going to be the amount accumulated for a child's college education. This is the end of our presentation.